Hi everybody. So this is Dr. Mori, and for today's mini lecture, we're going to talk about first a review about line angle structures, and then also how to use the molecule builder in LabPal for this week's lab. Line angle structures are difficult to say, but also they are a more efficient means of drawing a molecular structure. So oftentimes when we have very large or very complex carbon-containing molecules, it's a lot easier for a chemist to both read as well draw a molecule if it's drawn in this fashion. In a line angle structure, carbons are represented by either the start of a line or an intersecting point. Each carbon is satisfied with 4 bonds. So you're working under the assumption that you have the right number of hydrogens or bonds to other atoms so that every carbon has 4 bonds. No hydrogens are included in a line angle structure unless the hydrogen is bound to a non-carbon atom. And line angle structures are more commonly used for molecules that have more than 2 carbons in them. So the molecule that you see at the bottom of the screen is THC. And as you can see from the structure, there are no carbons, no C's drawn at all. Everything is just lines. The only places where you see hydrogens might be on some of the carbons, or more commonly on the non-carbon atoms. So how do we draw them? Well, first we have to look at the Lewis structure, or at least have an idea about what the Lewis structure is. So we're going to take these 3 examples, and let's start with the one over on the right-hand side, which is C5H12. So if I were to draw that Lewis structure, I'd have a carbon chain, and it would be bound to 12 hydrogens. Well, one carbon doesn't have 12 hydrogens, but the whole molecule has 12 hydrogens in it. Okay, and I want you to pay attention to how long it's taking me to draw all of these hydrogens in the structure. Right, it took me almost a little over a minute. Now, if I want to draw this in line angle, what I'm going to do is start with my pen on the piece of paper. So where my pen is right now, that's 1 carbon. I'm going to go up, that's carbon 2, 3, 4, 5. All right, and let me go back in and label my carbons. This is carbon 1, 2, 3, 4, and 5. And in my line angle structure, 1, 2, 3, 4, 5. Okay, so the zigzag helps me to kind of separate out the carbons, but every starting point or end of the line and every intersecting point is a carbon, and every carbon is assumed to have 4 bonds to it. So we don't draw in the hydrogens at all. All right, let's look over on the left-hand side at this alkyne. All right, so, and it's called an alkyne because I have a triple bond. So if I have a multiple bond, I want to show that in my line angle structure. So this molecule has 3 carbons. First, I'm going to start off with a 3-carbon chain. So there's carbon 1, 2, 3. Between carbons 2 and 3, I have a triple bond. Right, and that's my line angle structure. Then for our very last molecule, we have a ether. And that ether is surrounded by 2 carbons on each side. So we'll start with, let's just label it first, 1, 2, 3, 4. So I'll start with carbon 1, goes up to carbon 2, and then I'll draw in the oxygen, carbon 3, carbon 4. And I don't have double bonds or anything else, so that's pretty much it. When do we include hydrogens? Well, we include hydrogens when they're bound to non-carbon containing atoms. So let's go ahead and try the molecule over on the left-hand side. So this is a ring. So we're going to have the oxygen in the center. And then I'm going to draw the core of my molecule. So if I label my carbons, that's 1, 2, 3, 4, 5. Between carbons 1 and 2, I have a double bond, and the same between carbons 4 and 5. Now, at carbon 3, I have a carboxylic acid coming off of that. So I do want to include it in the structure. I'm going to go ahead and erase that 3. Redraw in my carbon, and then I want to show that I have that carboxylic acid. Okay, so this intersecting point right here, we can call that carbon 6, if you will. It's double bonded to an oxygen, and then it's also single bonded to an OH group. Now for the molecule on the right-hand side, we have an NH2 group at the end, and I have 3 carbons in a row first. So let's start off with that carbon chain. So carbon 1, 2, 3, and then carbon 3 is bound to a NH2 group. So I want to show that NH2 group, and I'm also going to put the lone pairs on the carbons as well, on the nitrogen as well. Okay, so that's the basics of drawing out a line angle structure. It's more common to find a line angle structure than it is to find a really big Lewis structure. Okay, so for this week's lab, you are going to use the molecule builder to build molecules, basically, in LabPal. So to use the molecule builder, you're going to come to a screen that looks something like this, and it will actually be embedded as part of a question. Now, what would be helpful is if you have a Lewis structure already drawn somewhere to reference. So the one that I'm referencing is going to be over here on the left-hand side. Now, in the molecule builder, you have a few different functions that are pretty useful. The arrow, or the cursor, is to select atoms. The eraser is if you make a mistake. The line is to create bonds. The C is to change elements. So if I click on all these things, erase would let me erase if I had something there. For the bonds, I can create multiple bonds, double or triple. And then for the C, that's to change elements. The rings is if I want to quickly draw a lot of different rings in a structure. And then the plus minus is if I want to add charges or if I want to add lone pairs of electrons. So let's start with our first molecule, which is NH3 or ammonia. Now what I'm going to do is draw a structure, not worrying about the kinds of atoms, but rather the core structure that I have. So if I select bond and then I just click, I'm going to create a bond between 2 atoms. Now what the molecule builder assumes is that those 2 atoms are carbons. So the core of my structure is going to be a central atom with 3 bonds. So I'm going to pick one of my atoms, this one over here on the right. When I hover over it, notice that it turns blue. I'm going to click again, that makes a second bond, and then I'll click one more time and that makes a third bond. Now there is no carbon in this, so I'm going to go ahead and change my atoms. So the central atom is going to be nitrogen. Now if I select this central atom, a pull down menu shows up, and I'm going to change it from C to N. Connected to the nitrogen are 3 hydrogens. Now this is going to assume that everything is carbon, so I also need to tell it that this is hydrogen. Okay. And then I'm also going to add lone pairs to my nitrogen. Cool. Click evaluate, and your molecule is good. Okay, let's look at our second one. So for our second molecule, we're asked to draw a line angle structure for the given carboxylic acid. So I'm going to start off again with the bond builder, and I'm going to click once. So clicking once is the bond between carbon 1 and what would be carbon 2. So the way that this formula is written, I have a CH3 group, a methyl group, and then I have 5 carbons before I get to the carboxylic acid. So if I click again, there's another one. And notice that every time I click, this is creating a line angle structure, which is super handy. Okay, so this is a CH3 group, CH2-1, CH2-2, 3, 4, and then 5. Okay, so the last part of this molecule is the carboxylic acid end. So I'll click one more time. Now this carbon at the very end is that COOH. But bonded to that, if I look at what I'm referencing, I have an OH group. So I'm going to click one more time, but then change the label. Also on this carbon, I have a oxygen that's double bonded. So I'll click here, change my bond to double, and then I'll change my atom labels. So this is going to be oxygen. This is also going to be oxygen. Now what you don't have to add is the hydrogen bonded to the oxygen, because the molecule builder will correct the number of bonds so that the bonding rules are satisfied. So I just typed in O, but it added OH, which is exactly what I need. Awesome. Okay, last one is to draw the molecule for the hormone estrogen. So I have this structure, has a bunch of rings on it, so I'm going to use the ring tool. Okay, so starting over on the left-hand side, I have a benzene ring, which looks like this guy right here. So I'll go ahead and click that and place it. And then I'm going to attach to it another 6-carbon ring. So instead of drawing the 5 carbons that connect to it, I'm going to select the 6-membered carbon ring and then hover over where I want it to be bonded. So I want it to be bonded right here where the blue is. And there we go. Okay, and then the second 6-carbon ring goes up here. And then bonded to that is a 5-carbon ring right here. Okay, and then let's add in all the stuff that comes off of the rings. So I have an OH group. So I clicked on the bond, click on this carbon. That's where I want the OH group to go. And then between, right here in this little valley, I'll put that CH3 group. And then right next to it, I have the OH. So then I'll go back to my elements, my atom changer, and then click on this. Change it to oxygen, and it will change it to OH automatically. And then change this one to oxygen, and it will also do it automatically. Okay, and then, oh, wait, I made a mistake. Okay, so I'm gonna go click my eraser, and then hover over this bond, and then erase it. Okay, so let's click evaluate. Awesome. Okay, so seems easy enough, but you do need to make sure that you practice with it.